Welcome back. Today's goal of this lecture. Today I will see those polynomial. First polynomial fx equal to x to the power 4 plus x plus 1. Second polynomial fx equal to x to the power 4 plus x square plus 1. Third polynomial fx equal to x to the power 4 plus 1. Today I will see at first is those polynomial is reducible or irreducible. For this, we all of us know, in my previous video I have seen mod p irreducible test. What is the mod p irreducible test? Let p be a prime number. And suppose fx in zx with degree of fx greater than equal to 1. And let f bar x be the polynomial in zpx which obtained from fx by reducing all the coefficient of fx in modulo p. If this f bar is the irreducible over zp, and this is for a very interesting, degree of f bar equal to degree of f, then we can tell this fx is irreducible over q. Also, we all of us know degree 2 or 3 test. What is the degree 2 or 3 test? Let f be a field and let fx in fx, and degree of fx is either 2 or 3. Then fx is reducible over the field f if this fx has 0 in the field f. Now I will see on our example. First example fx equal to x to the power 4 plus x square plus 1. Notice here degree of f is 4 which is greater than 3. But by root test, is any polynomial be reducible or irreducible? This is applicable for only the polynomial of degree 2 and degree 3. We all of us know. But here degree of the polynomial is 4 which is greater than 3. Then if we apply p equal to 2 in z2x, the polynomial f bar would be reduces. Obviously f and f bar would be similar. In z2 this would be x to the power 4 plus x square plus 1. Notice in f bar 0 equal to 1 and f bar 1 equal to 1 plus 1 plus 1 equal to 3 which is congruent to 1 in mod z2. But we cannot guarantee is this polynomial is irreducible, because here the degree is 4. Now I will see is the polynomial is written as to product of irreducible polynomial. Notice in z2x the polynomial is look like x square plus x square plus 1, x square plus x plus 1. But we cannot write product of this polynomial as a product of two irreducible polynomial, because in z2x these three polynomial has a root, so this is not irreducible, so cancel this part. Now can we write this polynomial by product of this polynomial? Notice for this here x to the power 4 plus x square plus 1. Just divide it x square plus x plus 1 for this at first x square, then this value would be x to the power 4 plus x cube plus x square then this value would be x cube minus x cube, just cancel this part, minus 1. Be plus 1, then just multiply this part by x, not only x minus x, then this value would be minus x cube minus x square minus x. Just omit this part, then this value would be x square plus x plus 1. Here would be just 1 because this part is equal. X square plus x plus 1, this value would be 0. So obviously we can write x to the power 4 minus x square plus 1 as a product of these two polynomials, x square plus x plus 1 times x square minus x plus 1. Sorry, here not minus, here plus. Here x to the power 4 plus x square plus 1. So, since we can write this as product of two irreducible polynomial, so obviously this polynomial is not irreducible over q. This is reducible over q, and since this is reducible over q, that means this is reducible over integer also. Notice here mod p test has broken because degree is greater than 3. Okay. Next I will say fx equal to x to the power 4 plus x plus 1. Is this polynomial is irreducible over zx or qx? For this, at first I will apply in z to x. In z to x, f bar x would be same, similar to before. This would be x to the power 4 plus x plus 1. Here also degree of f bar is 4, which is greater than 3. So we cannot guarantee is the polynomial is reducible or irreducible by root test. Notice here f bar 0 equal to 1 and f bar 1 equal to 1 plus 1 plus 1, which is equal to 3, and 3 is congruent to 1. Then x to the power 4 plus x plus 1. I will see is this polynomial is written by product of two reducible polynomial. For this, notice in z to x, the polynomial is such type x square plus 1, x square plus x square plus x plus 1. But these three polynomial, we cannot apply this three polynomial because in Z2 these three polynomial has a root. Now I will see, can we write this polynomial by product of these two polynomial, this type of polynomial? Notice here x to the power 4 plus x plus 1. Just divide it by x square plus x plus 1. At first this would be x square, then this value would be x to the power 4 plus x cube plus x square. Then this value would be x cube plus x square plus x plus 1. Now this x. Then this value would be minus x cube plus x square plus x. Then I will get here one remainder. Since I have got 1 as a remainder, so we cannot write this as product of these two polynomials. So obviously, since we cannot write this polynomial as product of two irreducible polynomial, so obviously this polynomial fx equal to x to the power 4 plus x plus 1, this is irreducible over zx also q. Next I will see fx equal to x to the power 4 plus 1. Is this polynomial is irreducible over z or q? For this, since degree of f is 4, which is greater than 3, so we cannot guarantee by mod p test as before. And if we consider p equal to 2, then at first check p equal to 2, in z to x we cannot retain x to the power 4 plus 1 as a product of two irreducible polynomial. So next consider p equal to 3. And in p equal to 3, that means over z3, f0 not equal to 0, f of 1 also would be not equal to 0, f of 2 also would be not equal to 0. So since this is not equal to 0, in z3, since this has no root, since degree of the polynomial is greater than 3, so we cannot conclude about reducible or irreducibility. Now fx equal to x to the power 4 plus 1. In z3, x square plus 1, obviously this is irreducible polynomial in z3. And if we divide x to the power 4 plus 1 by x square plus 1, then this would be x square, means this would be x to the power 4 plus x square. Then there would be x square plus 1, and then since this is x square plus 1, so this would be 1, x square plus 1 would be 0. Therefore, we can write x to the power 4 plus 1 as a x square plus 1 times x square plus 1. So, since we can write this as product of two irreducible polynomials, so obviously fx equal to x to the power 4 plus 1 be reducible over q also over z. I hope my all viewers have understood this is clearly. Okay. Well, let's see one question which had come CSR NET June 2017 exam. The question is, which of the following polynomial are irreducible in zx? Option 1, x to the power 4 plus 10x plus 5. Option 2, x cube minus 2x plus 1. Option 3, x to the power 4 plus x square plus 1. And option 4, x cube plus x plus 1. For first option, I will use Eisentiens criteria, because we all of us know this is the Eisentiens criteria. Here, x to the power 4 plus 10x plus 5. For this, the criteria is if there exists a prime p such that p divide a naught, p divide a1, p divide an, but p square does not divide a naught and p does not divide an, then fx is irreducible over q. Here, consider p equal to 5. And for this prime, obviously 5 divide 5 divide 10, but 5 does not divide 1 and 25 does not divide 25 does not divide a naught. Here a naught means 5. So for this prime p equal to 5, for this polynomial, Eisenstein criteria is used. So this polynomial is irreducible over Q. But in the question indicate the following polynomial are irreducible in ZX. For this I will use Gauss lemma. A non-constant polynomial in ZX is irreducible in ZX if and only if it is both irreducible in QX and primitive in ZX. What is the primitive in ZX? If primitive means GCD of all coefficient if 1, then we can tell this is primitive in ZX. Here notice the polynomial is x to the power 4 plus 10x plus 5. Then as GCD of 5, 10, 1 is 1, then we can tell fx is irreducible in ZX. Okay. Our next example, x cube minus 2x plus 1. For this, we will see some rules at first. And this type of rules are actually very important for reducible and irreducible test. First, if f is a field and fx belongs to f of degree 1, then fx is irreducible over this field f. That means if the polynomial of degree 1, then it is irreducible over the field f. As for example, fx equal to 2x plus 6, x minus 6, all are irreducible over R and Q. Second, if f is not field, then above result need not be true. 2x plus 6, this is irreducible over the field, but this is reducible in Z. It has a root in Z obviously. At the point x equal to minus 3, it has a root. That means all linear polynomial be irreducible over the field but not reducible at the point x equal to minus 3, it has a root. That means all linear polynomial be irreducible over the field but not always true when f is not be a field. Third, fx in ZX and degree of fx greater than 1, then fx is reducible over the complex number. That means when degree of polynomial is greater than 1, then always over C there exists a root. Fourth, if f is a field and fx belongs to fx and degree of fx is greater than 1, then fx is reducible over the field f if f has a 0. That means if f has a 0 in this field, then always we can tell this is reducible. But for irreducibility, if f has no root, that means f is irreducible. This is not true always. This is true when degree of f only less than equal to 3. That means when degree of f less than equal to 3, when f is either second degree polynomial or third degree polynomial, if there exists no root, then we can tell the function fx is irreducible over the field. Now let's come back our original question. X cube minus 2x plus 1 in Z2 obviously this function fx in Z2 has a root f of 1 equal to 1 minus 2 plus 1. Obviously this is 0. So in Z2 f of 1 has a root. So since it has a root, so obviously this polynomial is reducible in Zx. And here the question, which of the following is irreducible in Zx? Option 1 is right, but option 2 is not true. Now let's come back our third option, x to the power 4 plus x square plus 1. Few minutes ago I have seen, since here the polynomial is degree greater than equal to 3, it has no root in Z2x. This is true obviously, but it is written as two irreducible polynomial, x square plus x plus 1 times x square minus x plus 1. So this polynomial is not irreducible. Few minutes ago I have seen this is 4 x cube plus x plus 1. Here I will apply the mod p test. X cube plus x plus 1 in Z2x. Consider this is fx. Consider in Z2x f bar x would be x cube plus x plus 1, and in Z2x f bar 0 equal to 1, f bar 1 equal to 1 plus 1, which is 3, which is congruent to 1. Therefore, for this prime p equal to 2, f bar x is irreducible over Z2. Mod p test, we can tell, since this is irreducible over Z2, therefore this is irreducible over Q. And since this is the primitive polynomial, because GCD of 1, 1, 1 equal to 1, so irreducible over Q always imply irreducible over Zx. So option 4 also right option. Today I will stop here. In my next video I will discuss some more question about this topic, because this topic is very important for any competitive exam. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.